All right, sweet, it's going. But also just be candid. Don't feel like you gotta also be stiff. All right. We're on the homework. We're on the homework. Do y'all want to start? Oh yeah. Let me actually.
Because you just took it and I just realized I messed up.
All right, so where are we? What do y'all want to start on?
I'm gonna be really honest, I didn't do anything when you left, so technically I'm still on question 4.
Okay.
Yeah, he has started.
Yeah, I'm what do you call it? A pop-up.
Download.
What? My driving class is a pop-up. Yes.
I thought
You can turn it on.
Oh, I didn't. Hold on, man. I didn't download first. I thought I downloaded the whole worksheet. Oh, hold on. Well, I guess let me pull it back up on mine. I'll stop. I'm gonna stop that. And restart it. Sorry, guys. I don't know what I did with my exam 2 worksheet. Here.
I'm pretty sure I drank that energy drink more than most people should.
Collection.
I mean, I got greenies in there, so I don't know. Give me some cookies. I got that cookie juice in there.
There's a week. It's in week 2. There it is, week 2 worksheet. Yeah, I thought maybe I just opened it in the browser. Anyways, okay. What number you guys?
It's not. It actually is tea.
4.
It's
4.
tea. Green tea. Like, what are you talking about?
All right, sweet. All right.
It's just C. That's it.
4. All right, sweet. On 4.
I had 8 of them a day.
All right. So 4. So we have tangent squared x plus cosecant squared x is equal to secant squared x and plus cotangent squared x. Cool. Number 4. All right, awesome. So you essentially you pick a side, and we're only going to work one side or the other. So it's like, what side do y'all?
Left.
I'm gonna go left. Okay. So we're gonna work this guy. Work this guy. Okay. So what's kind of like the first thing you kind of pull from like the toolbox, right? Like what is going to be the first thing to pull, or what you're thinking about a relationship that exists between, and remember what I'd said, like what pairs of trig functions are always connected. Do you remember me saying that? It has to do with like the identities.
Is it the 1 plus 10 or?
Well, it's like the regular identities. Like whenever you're memorizing them, you have sine squared theta plus cosine squared theta equals 1 is one of them, right? And then the other one is 1 plus tangent squared theta equals, do you remember what this one is?
See.
Yeah, and this is kind of what I mean by forever paired. Sine and cosines are always together, tangent and secants are always together, and then cotangent and cosecants are always together. Oh. So whenever you're looking at these, you're thinking about these kinds of ideas. Anytime you see squares, your mind should kind of be thinking Pythagorean identities, right? And the next one is just 1 plus cotangent squared equals cosecant squared in the same form. So you would want to use one of these guys to kind of attack this problem. So I'm gonna just to keep it in the memory. So
So do we try to find something that equals 10 or something that equals something on the other side?
Yeah, so you want this to transform into this. So what could I do to tangent? And you know that tangent is related to secant in some way via the Pythagorean identity. So you would kind of think in that methodology. You would say, what can I do to transform this into this? What can I do to transform this guy into this guy? We're going to leave this guy. This is our goal. Like it's like we're starting here in the forest, and this is the end. You know, point A to point B. That's where we want to end up. So what do we use on that tangent?
That second item.
Yes.
1 plus 10 squared theta equals secant squared theta.
Right, right. So now you have to solve for tan by itself, right? And move it over, you know what I mean? Because this is kind of like that, those are like the general forms that they're in. You know what I mean?
We don't just like add 1 to it.
Yeah.
And equal that same thing.
That's what I mean, yeah. So if tan was by itself, the identity would actually be what?
That's a really good question.
It'd be secant squared theta minus that 1 that we moved over, right? Right, because it's 1 plus tangent squared equals 1. So if I move the 1 over, this is what I mean. So like algebraically manipulating them. Do you see what I mean? It's like a tool. That's just the base form to memorize, and then you move them around to like, to get that. So cosecant, what would the move be? So let me get awesome.
Cotangent minus 1.
Yeah, exactly. Or no, wait.
Not cotangent minus 1.
Right, because it's already equal to. So it's. Yeah. So it's already equal to it. So it's 1 plus cotangent squared theta, is it not? Or we're doing x's here. Sorry. So these should be. You want to keep your angles the same. So we're saying x's, and this is x, right? Right. So that's what that transformed into.
Yeah.
Do you see what I mean?
Yeah.
Cool. Yeah. And then so on this side, this thing just stays the same on here. And so then all we do is just, because do I have a secant?
Yes.
Do I have a cotangent?
Yes.
So I just cleaned it up, right?
Yes.
So what ends up happening?
The ones cancel.
Yeah, the ones cancel, and we're already done. Yeah. So minus 1 plus 1 is 0. So we are left with our secant squared in one step, right? See, some of these are not. Professor Vargas is being super cool to you guys. Like these can get pretty crazy, and this is not terrible, right? Does that make sense?
Yes.
Yeah. So it's kind of like, it's like having those original ones memorized, and then you're just kind of thinking to yourself, what's the closest relationship? Well, tangent is like intertwined. Well, it's got tangent, and also tangent does have more than one, right? Because tangent is also sine over cosine, right? So tangents and cotangents are like super versatile.
So
All right.
those cancel out.
And then we've got your.
That plus that equals that plus that.
Right, and it equals.
I got it.
Are you kind of seeing how it?
Yeah. I think cotangent.
And you can memorize these in any format you like. I just happen to memorize them this way, so you can move them around. Yes, yeah. This is like and I did send a digital one to y'all's email too, so you can use that as a guide. Just either use that, make your own. It's better. They know it's better if you make your own because it's in your own handwriting and you see it, and like the process of that textile learning, they know that improves. Cool. All right. So next one. Number 5. Let's go. Yeah.
How many did we make them do the last one?
30.
30?
But he
That's-
doesn't tell us how much
There's
Yeah.
a lot of this.
I would.
we need to. And the last time we did, he said that we could go up to. He said we could go up to 53, 54.
Oh yeah. From just yesterday's lessons, you can already go that far up. Yeah, and y'all said 5. Were you doing 5?
Unless you want to skip to something else.
No, I mean, no, this is for y'all. Like, what do y'all want to do?
We can do. Let's do simplifying.
Okay, simplify.
Oh, what we need
Sign
to-
something different. Let's start with 12.
Okay, 12.
Yeah.
All right. Do 12. 12. 12. So I have sine of 6. 6b.
You're doing the bones. What is
And
wrong with you?
cosine
What is wrong with you, this lady?
Five.
Are you okay today?
minus
You're not okay.
cosine
You should.
of 6v, and then sine of 5v. Okay, right on. All right, sweet. So, okay. So so this whole section is about pattern recognition. Essentially, it's like, do you see a pattern in one of your identities?
Yes. So is it like, what is this asking us?
It's saying simplify it. Basically, contract this into a single thing. Simplify usually means reduce and reduce until it goes down to oblivion and be. And
So 6 divided by 6.
this is the great
Can't
singularity.
you just do sin?
Yeah, you're on the right track.
Sin divided by cosine?
No, not that. So we're approaching another kind of tool in the toolbox. I know this is off camera, but we're kind of
We're over there now?
yes.
So it's sine. Oh.
Do you
so
see the pattern?
the alpha and then the
Yeah. So tell me what so this would be like sine alpha first angle, right? Cosine beta second angle minus cosine. Are these the same angle?
Yeah.
Yes. Alpha same angle?
Yes.
Yeah. So it's like what is that? What does this equal?
Like, that's not an alpha.
So essentially every one of these problems is drilling you, do you know this identity? That's what a lot of these problems are actually saying. So what is this identity?
Sine alpha minus beta.
Sine alpha minus beta. Awesome. That is right. Yeah, so it's sine alpha minus beta. Yeah. Sweet. Okay, so- Nice. Okay, yeah. So essentially, now you're just taking. We're on 12, dude. And so now you're just like, if there's not too much simplifying, right, at this point, because then what do? We just all this becomes this thing on the left side of the equal sign, right? So it becomes all of that becomes sine of 6v minus 5v, right? That's what everything becomes, right? It just condenses down there. Yeah, I mean it's pretty much this whole thing is just drilling you. Do you know the identities? That's like, so you can get into big trouble like in this from this part of trig on if you don't like own these, especially for all the engineering people, and going up to calculus 1, you're gonna see all this again. I know I keep saying that, but it's like
No, I feel targeted in this
Yeah,
because you keep saying engineering. You don't say nobody else's name but
well,
engineering.
I mean, because this is your future. Your future is now. That's what this
I'm
is.
the only one who's
Yeah. Yeah, I think yeah. Everybody in here is an engineer except pharmacy. But I mean, Cal 1, you gotta know it. Okay, so all right, yeah. So this comes down to here, and now what do we do? Because the name of the game is simplify. Yeah. Yeah, it's so this ends up just becoming sine v. I was gonna say negative
You
v.
don't even have to put it in parentheses. You just leave it out.
Yeah, there you go. Yeah. I like the parentheses because it helps me remember this is a function. Whenever because in the future there's gonna be a bunch of math around this. Like the trig function will be inside of a big expression. Okay, so that's our answer here. Awesome, not too bad. So this question was really not too much thinking, but rather, do you just know that that's a difference identity, right? Okay. So Daniel, since you came in next, do you have a question anywhere specifically? Just
trying to memorize everything.
Like that's what's this in. I can say that this whole section, it almost if you conceptually understand this, your real success for this next thing is the memorization itself. Like if you just have these identities down and you get the idea, like, okay, I'm transforming something. Everything is transforming. So it's like if you this is going to be 100% based off of how strong you know your identities. Period. Like that. This whole section. Like because there's going to be almost no way to figure this out if you don't know that formula. Like I mean, are you gonna? If you don't know the formula, I don't think you're going to randomly come up with the proof that proves the formula, right? You know what I mean? It's not going to happen. Okay. All right, cool. So next, so 12. We can skip around. It doesn't matter. Questions from today. It doesn't matter to me. Whatever is going to be helpful for you guys.
I think the thing that really helps me throughout the entire, all of this stuff is writing out every little thing.
Yes.
Even if that's going to take me 10 extra minutes.
Yeah.
Okay.
Yeah, because it was kind of like I saw in your face whenever I moved that one over, you were like, you had one of those, I know it clicked, and now you're going to remember that. So that's what I'm looking for in y'all's faces is that, oh. And then you kind of, is that, you do the, that's you do the problem? Is that right? I'm old. Okay, what, so from 12 on.
14.
Okay, 14.
Is this the one where you have to figure out 2 angles that add up to that? Or, no, it's not. That's not what it is. Never mind.
Well, what's crazy is, I mean, technically you could. That would be, I think, a harder way to go, but you could. That's the thing with a lot of these is you can really. I think I have the better black one right here. Okay. 14 sine. Try to write big here. Sine 35 pi over 18. We have cosine 5 pi over 18 minus cosine of 35 pi 18 and sine of 5 pi over 18 like that. Okay? Right on. Yeah, go for it. I just really like the parentheses. Like later, I'm gonna recommend you build that habit because I don't know, maybe you don't need it, but when you start seeing a bunch of other identities wrapped around this, you get into vector value functions and all this kind of stuff. I think the parentheses up. Anyway, so what do you all notice about this?
So subtracting sine.
Yeah, it's a sign difference identity, right? Yeah. I mean, and once again, the name of the game is do you recognize the pattern? Alpha. These angles are the same. These angles are the same. Beta. My beta doesn't look like that. Beta, right? So then it just reduces into what? You get your sine. You have your first angle, 18, minus second angle. Okay? Do these feel easy, right? Do they feel that way yet? I mean, it's probably like
I'm not the best with the formulas.
Yeah, because it's working a different type of your brain. You're used to so much algebraic manipulation, and now this is straight memorization. Do you just know this formula? So,
I get when you use a positive, when that sine's flipped and all that.
yeah. So sine Sine is same sign. So if the sign here, if the sign in the middle with and you see this, like, I always remember that the first trigonomic identity is the identity. So so for instance, that sine double angle or the difference angle, you have that sine minus right here like this. Well, guess what? Equal sign, the first trig is the same one that's right here. And then it has the long stuff over here, right? If it's cosine, guess what? The first one's going to be cosine, right? So that's kind of like to start the pattern, like making small associations like that. You got to just kind of do whatever sticks. And you're not going to know that, like, what sticks for me may not stick for you. Like, I see that pattern. I just know the first one. Because it's the same with, like, whenever y'all did the sine double angle right here, this identity, I always know that it's 2, and I always remember it as the sine is the first one. And sine and cosine are typically always, like, intertwined. Where you have a sine, you're probably going to have a cosine in an identity. Kind of. Like, again, like, it's just kind of, that's what sticks in my head, in a way, right? So, those kinds of ideas. So then right here, this literally is just basically asking you, do you see the pattern? Same, sine. So sine, cosine, sine, same, sine. Like, that's like a jingle. Again, I don't like that, but it works, right? So you can know that jingle. I think of it as more like as like I'm looking in a mirror, and I have a reflection on either side. You know what I mean? And then I just know that the angles just repeat themselves.
Is that only for sine, or is cosine just like that too?
No, it's different. That's how you can remember it. So this is sine. Cosine is like this. Cosine is cosine alpha. Cosine. They have 2 cosines, and then here let me draw the left side one as well. So we'll say minus plus, and this is going to be your cosine alpha plus minus, and then I can explain what that means more. And then we have sine alpha, sine beta. Do you see how they're different? So sine they're mixed. Cosine, they're not mixed. 2 cosines, 2 sines. Sine has both on each side. That's how, and I just kind of like, I don't know, I don't really know a great way to memorize that other than, like, you got to stare at it for a while. Just this is the part where this is the part of trig where people kind of get like bogged down, because there's no easy way around it. You just got to figure out how to grab that and inside the brain. There's no other way around it. So whatever makes sense to you. And then this just means that the sign flips here. So if it's positive here, it's negative here. If it's negative there, it's positive here. Sine, it's the same. What you see is what you get.
So it's basically partners. So like cosine,
Oh, that's a good way. Yeah. See those little pneumatics like co-partner, cohabitate, those kind of. Yeah, that's a perfect.
Sine, draw the line.
Boom. There you go, dude. Yeah, like exactly. That's great. Sine, draw the line. Yeah. I mean, like I'm telling you, like those types of things are gonna like save you. Like, I mean, that's great. I like that a lot. Okay. So that's the difference. And so then just to sum this one up, all you do is denominators are the same. You just add them up, right? So 35 minus 5. Yeah, are we done there though?
Simplify.
Yeah, simplify. Yeah, so divide by 6 is probably even bigger. See, me, like I choose small numbers because I'm not really good at that, and then I'll eventually get there. So yeah, so that ends up being, if you do a 6 there, you get the 5 pi 6 there, and you get the 5 pi over 3. What kind of, and then I'm gonna push y'all one more. What kind of reference angle is that? Try not to look. It's like, what kind of reference angle is this? And where is it located? It's in, not 3, I think 4. The reason is, think like this. Remember those, like, so in your quadrant you have over here is pi, right? And this is 2 pi over here, right? So 2 pi would be the equivalent of that, right? So it's 1 less.
Ah.
Yeah, if it was 4/3, that'd be 1 more than 3 over 3, right? That's how I think about it. That's my quick way to know, hey, where's that at? So is this angle, is that or this ratio that would come out here? Can y'all tell me what it is without looking? Yeah, you know it's going to be negative because all students take calculus. Yeah, and then this is how I remember the reference angle underneath here. 3, when you see a 3 in a denominator, what kind of reference angle is that? And you're just kind of thinking quadrant 1. When I see a 3 on the bottom, what kind of angle is that? From horizontal. If I come up, what is one of the, because this is a...
Square root of 3?
Yes, you're right. Yeah, you're closest. So it's what is it?
Square root of 3?
It's
Not just that, but
Over 2.
yeah, square root of 3 over 2. Because it's a 60-degree angle, sine at a 60-degree angle is the square root of 3 over 2, right? So I'm just trying to if you do the overlapping layers, increase clarity. I had one of my favorite professors says that, and so yeah. So you hit this and boom, right? Feeling good? Nice. It's not asking for that, but why not? It's there.
Maybe it's not scroll back.
The question is just what's this? I'm just asking you, do you know that ratio? Because this is a special angle that you need to know. So I'm just kind of asking one more step. Because you'll need to know it at some point. Oh, no, they did ask that. Sorry, they did ask that. So, boom. Answer. So I'm not always looking at the answer key. Awesome. Okay, sweet. So, so what's next? Are we going on 15? Anyone have a question? Or concern? I can erase this one?
Yeah.
Sweet. Awesome. Yeah. Okay. Nice. All right. So what's
One knows better. How the relation.
Yeah, whatever. Yeah, man. Whatever. And really, I mean, it really is that. It's like I draw it like this. That's how I think about it. You take. It's like Play-Doh. You go play and make what makes sense to you, kind of thing. But with the same Play-Doh in that analogy. Cool. Next one, guys. 15, 16. Do you want to go to the next? Do you want to skip to the verify stuff? Some difference. Sure. Skip up. Okay. Let's hit what 21. Does it sound good? Or did we do 21 last time?
No.
I don't think we got that far, right? Okay, let's run 21. Or do y'all have another one? 21 sound good? Great. 21. 21 sine. We have this angle theta, 270 degrees, and this is going to equal a negative cosine theta. All right. Okay, and it's just saying verify the identity. Verify it. So what would be the first approach? When you hear the word verify, what does it mean to you? I guess yeah.
I never understood why he said verify.
Yeah, verify, when you just hear that word, because you're going to see it on your test, when you see hear the word verify, it says, hey, work one side to make it match the other side. That's what it's saying. Just verify, because it's basically saying this equal sign, it's going, are those equal? That's really verify. Can you verify this information for me? Are those the same? So, and then the rule of thumb is to always go from big to small, in verifications, because it takes greater imagination to create stuff on this side to become that, but it's easier to take something and condense it down to something smaller. Cool? All right. So what would we use here?
The sign, Sine alpha plus beta equals 1.
Yeah, it's a sum identity of sine. Perfect.
That's the word.
Yeah, yeah. So you have your so you go. You know that this guy is your alpha angle, and this guy is your beta angle, or your first angle, second angle, however you want to say it. And then you just you expand that bad boy out right here. So, or will you? Yeah. So sine. So what is it? Y'all tell me. What is this?
Cosine 270 degrees.
Okay, cosine of 270 degrees, and then what goes here?
Plus
Perfect. And then
cosine
of theta.
No. No.
Wait, is it?
Yeah.
Is it?
Yeah.
Are you sure?
Yes.
Okay, yeah, that's right. Okay, what's
Close
next?
the line.
Yeah, you gotta be confident. You gotta go, I know for sure. Yeah. Okay, yeah, so it's first angle, second angle, sine gets the line if you like that, and then over. Yeah, great. So, okay, so what is it? Is 270, is that a special angle?
Yeah.
Yeah, it is a special angle. So what is, oh, well, this is very nice. Notice, where is 270 at? It's not, because if I ask you what quadrant it is it in, what quadrant is it in?
I'll say 3.
Right, it's on the line, right? Do y'all remember I used a vocabulary word for this? Do y'all remember what that was called? A quadrantal. Yeah, it's on the quadrant. Okay, so these are special. Do y'all remember these identities? This was a part of your chart you had to fill out. Do y'all remember that this is an important one to know, that sine is equal to y over r, cosine is equal to x over r. Do y'all remember those? Right? Okay, so how big is a unit circle? What is my radius of a unit circle?
1.
Yeah, it's 1. So this is like 1. This is how much? Yeah, but it's not just 1, it's -1, right? Yeah, because the thing going in between here is an x and y axis, right? Like you're used to in algebra. You have that x, y axis. This is 1, -1, +1, -1. That doesn't look like 1 at all. Okay, like that. So if I'm here on my quadrantal at 270 degrees, right here, 270 degrees, what is my, let's do our cosine first, what is my x value here? It's a 0, right? Yeah, because I'm at 0 value of x. So cosine, this guy is 0 over what? Yeah, 0 over negative. And anything under 0 is 0. Yeah. So this guy is 0, which means anything times 0 is nothing. It just goes off to 0. So that's 0. Okay. So now over here, sine of 270 degrees. What is my y value here? -1 over. Yeah, -1 over 1. Why is it not -1 over -1? Why is it not that? Wait, say it again? Yeah, r is always positive. Radius. The radius of a circle. Can you have a negative radius of a circle? Not as far as we know. I mean, like, I think when you get more advanced math, maybe. I don't know yet, but yeah. But that's right. So it's -1 over 1. So this value is really -1. So if I clean all this up, I'm gonna get rid of this identity. Those are good to remember. Know those? So if this cleans up, what do we get? Which is, yeah. And that's our answer. Booyah. But huh? Yeah. Yeah.
You're eccentric, I like it.
Yeah. Sweet. Okay, what's the next? Do you want to keep doing these? Do you want to hit the next conceptual one? Because we got like, if y'all are only staying until 7, we got 20 more minutes. So we can either do practice or keep. When I say practice these, we can move on to the next concept.
Next concept.
Next concept? Yeah, I think it's good because y'all need to practice on your own. So this is a great place to work out concepts because I can go into that quadrantal stuff. Remember that, you're going to need it.
I think it's good to knock that one from each category, so when we go through it, we can have one to look.
You have, I think, yeah. Yeah, and then now that I'm doing the recording thing, you can like skip ahead to whatever you need just to kind of refresh if you need it. Okay, so then we're gonna go, let's see, we've already done, so that was what, 21? Okay, so, do we really need to do a cosine sum and difference, or do you get that concept? Because we've already, so, and I guess what I'm saying is the procedure is exactly the same. The only thing you're using is the identity of the cosine sum and difference. Let's do one, like just real quick. Just to, okay, so 25. And you'll see what I mean, like, so cosine of negative 4x, cosine of, and already bells should be ringing, right? When you see cosine and cosine together, what should you be thinking about? Wait, what is it?
Difference of cosine.
Yeah, difference of cosine, right? Because like when you see the same but different. Y'all know that movie? Okay. Sine, and then you have sine of 3x. Yeah, and Daniel nailed it. Like it's your cosine. It's your cosine identity. So like what is this? So you have your first angle, right? Is that the same as this one? Yeah. And that's why I always think that never changes. It's always first angle, second angle, first angle, second angle, no matter if it's sine or cosine. The only thing that changes is both cosines, both sines, and the other one is sine, cosine, cosine, sine, blah, blah, thing. It's out of that. Okay, so then what does it shrink down to?
Cosine of alpha minus beta because it's opposite.
Yeah, so you got your alpha, and then it's plus, good, so minus, and then beta. And what does that come out to?
7.
So cosine's opposite of that negative sign.
Yes, yeah, and that's the meaning. Like whenever you see in any math book, you see a plus, and you have something equal over here, and you have a minus plus. It says if it's plus here, it's minus there. And if you see them look exactly the same in the math book, it means if it's plus here, it's plus there. If it's minus, it's minus there. That's that notation you're seeing.
That was a little sheet he posted.
Yeah.
Something different.
Yeah, that's a very mathematical way because it's like, instead of writing it twice, they came up with this notation just to, because math books would be even thicker. Okay, so then you just add them, right? So negative 7. Oh, I'm going to push the concept a little bit farther, and I'm going to see if he does it here. Oh, he doesn't. Okay. What is this also equal to? There's an identity y'all learned in the first unit.
7x.
It's what? Wait, say it again.
Negative cosine 7x or something.
Oh, very close. It's not negative cosine, but it's.
Oh, it's just positive.
Do you remember why? Like, do those look equal? They don't look equal, but are they?
I guess so.
Yeah, they're equal. So it's like the reason why is okay. You got your unit circle. Yeah, right? Remember, we have the all students take calculus idea, right? Okay, so if I'm at this angle, and like let's say I come up to a positive 30-degree angle, is cosine positive here? Yes, cosine is positive. Okay, if I go negative 30 degrees here, is cosine positive? It is. That's why. You see what I mean?
Oh, yeah.
That's why. All students take calculus. This is also a positive, a negative angle, but you get a positive ratio. That's why. It's an even, cosine is even. It's the only one that's even. I don't know if you remember Professor Vargas saying that. He was like, it's easier to tell you that cosine and its reciprocal, which is secant, is like this. So anytime you see this, like let's say you're doing a verification and you end with something like this, guess what that is equal? So don't let it trick you. Because I don't think Professor Vargas is going to do that to you, but there are teachers who will. And also too, just know like someday you're going to be calculating something very important, and if I tell that builder, is it the same this way, is that bridge going to fall down? And the answer is no, it's the same. You're good. You know what I'm saying? I mean, this stuff is important for the engineers and anybody. I mean, really. Okay, cool. Are we good? Nice. Okay.
Where did you get numbers from?
Oh, I was just example. That was just an example. Yeah, sorry, that was just an example. Like this, I just picked an angle because we don't know what the value of x is, right? It could be, but negative x is the same distance as positive x away from this midline, and so if this quadrant, it would be in the same quadrant on the left or the right side. So theoretically, it's always even. You know what I mean? Okay.
So, like, the first one was like for 100 degrees and negative 100 degrees.
Yeah, it would be what would be cosine of 100 and negative 100? Was it be a positive or a negative outcome?
Negative.
It'd be negative. Yeah, they'd both be negative because they're on this side now, where cosines is negative. Yeah, that's why. All right. So 20. Let's move to. Okay. Let's do. Do you want to do an exact value, or do you want to just move on to 31 or the 30s right there? That's where we were at today. Do y'all notice that? That's where what he was talking about today, actually. So I guess maybe you couldn't. I mean, technically, y'all could have gone up to 50 by yesterday's work, but do you want to do that in the 30s?
The 30s?
Yeah. Okay. Let's do. Let's do 31.
I was just thinking of that one.
Nice. Yeah, and then also feel free to work ahead. You know, y'all don't have to. You know, this is your time. You spend it how you want. You can ask questions. If you already know what I'm talking about, just move on to something new. And just use this as a way to crush your homework and get it out of the way. You know what I mean? And get help at the same time. You know, it's set up times to get get stuff done. Let's see, 31. No. 31 cosine of 13 over 12, and it's asking us to find an exact value. It's like it's saying it's a exact value. What do you you're given that, what do you have to do? Because when it says exact value, what does that mean?
Like not decimal.
Yeah, not a decimal, but even in more simple terms. Because what goes inside of the trig function? What is that? Huh? A what? Pi? Well, I mean, there's pi there, but what is this thing? I think you said it last. It's an angle. Yeah. So if you put an angle into a trig function, what do you get out of that trig function? If you have your trig function and you throw an angle inside of that, what kind of output? This is input, this is output. That's what functions do. What is the output? Just in a general term, angle, and then this is it's just a ratio. Or you can just think of it as it's just a number. That's all it is. It's just a number. Like these produce numbers. They come out as some kind of number, a value. Okay? I just want to make that, because if you know what the words are saying, it makes it easier to solve the problems, I think. Okay? All right, so what do we do?
We have to convert it to the degrees.
Yeah, that's a great way, because it's hard to, because it's like, what is that angle, right? What I did say one time, if you see a 12 on the bottom, what kind of angle is it? Do you remember?
Increment
Nailed it. It's in some kind of,
Genius.
yeah, it's in some kind. So what quadrant would that be in, even before we start? Where would that be? Quadrant. Huh? Yeah, because it's 1 more than pi. So what is that? You already know what that angle is. What is it? 180 plus 15. Yeah, 195. That's 195 degrees. We didn't even need to do the conversion. You see what I mean? Like if you kind of the overlapping layers, right? Like you see it in, you know more than you think you know already. Okay, so we already know that we have cosine of 195 degrees because we just added, we're in the third quadrant, and we just added 15 to it. Okay? So now what do we do? Now that we have that, what does that mean?
We have to split it into two angles that either add or subtract 2.
Perfect. Okay, so when you have a 5, what angle or what kind of reference angle are you always going to choose? A 45-degree angle to get to, because you got to take care of that 5. Okay, so on my scratch work over here on the side, we're going to say what equals this. I guess what plus or minus what is going to equal my 95. What do you want to do? You want to add up to it? 20 and 45. We're going to add up. So I usually, since I know one of them is going to be a 45, I just take 45 and minus it out and see what I get. So yeah, you get your 5, right? 150-degree angle. Did I do that right?
Yeah.
0? Okay. 9, 8, 10, 11, 12. Yeah. 9. Yeah, 50, 158. Do we know, and you always have to double check, is that a special angle that you know?
It should be.
Right, yeah, these are, yeah, they're not trying to trick you, yeah. It is a special angle. What quadrant is this in? Quadrant 2. What reference angle is that?
30.
Yeah, okay. So, I almost want to challenge you. Do you think you can do the ratio right off without even having to write the stuff out? You think you can? In your mind's eye? What in cosine, what's first here? What trig identity comes first? It's a cosine. It's going to be a cosine, and we're just going to say of one of these, right? And then it's a of something, and then what are we doing? Yeah, because we're adding those two to get that. So this is going to be a subtraction, right? Yeah, and then we get sine of whatever is going to be in that first one, and a sine of whatever is going to be in that next one. Okay? So we're adding, so does it matter which one I choose first? No, because addition is this, right? 45 plus 150 is the same as 150 plus 45. It doesn't matter. So we're going to throw in our 45-degree angle. I'm just going to pick that one first because we thought of that one first. And then we say 150, and I would challenge you, try not to look at the deal. Can you give me those ratios? You know your reference. 45 is the easiest. What is it?
200.
Nailed it. Okay. What is cosine of 150? It's you have to think like, is cosine negative or positive there? First, give me that. Is cosine negative in quadrant 2?
Yes.
Yes. Okay. What is 150 is a what kind of reference angle? 30. What is cosine of 30?
Square root of 3 over 3. Or
Square root of 3?
Square root
Yeah.
of 3 over 2.
There you go. Yeah, square root of 3 over 2 is a... Yeah, this is awesome. You're already getting quicker, right? It's not that hard. Still got it. I'm going to put this in so we know those are multiplications. Sine of 45, it's cake. What is it?
Square root of 2 over 2.
Yeah. Okay. All right. And then we get... is sine positive or negative in quadrant 2?
Negative. Oh, no. It's
Yeah. All
positive.
students.
Actually
All
positive.
yeah. Okay, so we get it. And also remember in your graphing, right? You get the hump like this. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. These are negative below the line. Those are positive, right? Just to solidify, right? It's the same stuff. We're just looking at that this way. Okay, so we have positive. What is we know this is a 30-degree angle. What is the sine of 30? 1/2. Yeah. This is sine 30. Just make that like a starting place. Sine of 30, not crush it. Okay. So that's a multiplication right there. By the way, like I don't know, does this look better to y'all? Do y'all like that better instead? Anyway, okay. So then we multiply that together, what do we get?
Square root of, or negative square root of 6 over 2, right? Or over 4.
Ah,
Over 4.
there you go, okay. And then,
It's the square root of 2 over 4.
yeah, okay. Can I put those together?
Yeah.
Yeah, because
Same denominator.
same denominator. Yep, there you go. Just put them together. Right, and then I guess I'll just this for the,
For the sake of
yeah, just boom. Well, yeah, because some teachers, I'm going to tell you right now, like Hobbes for physics is going to mark, you can do everything right, and if you like, I don't know, if you've made a smudge over here, it's wrong. I'm not even kidding. I hear stories about this guy. Like, I'm gonna have him this next semester. Well, because it matters to be as meticulous as possible. Because if somebody misinterprets your work, what and you're building a bridge, it's kind of like, I know I'm bringing that point up, but that's a reality. That is a reality. Okay, all right, sweet. 31. We're sitting right there at 7. Y'all are welcome to stay or go. Will I stay or will I go now?
Yeah. I
Good.
think main more important thing around is just like learn all this.
Yeah, that's
not big.
yeah. Number one, if you haven't buried your face in these identities over here, then you are already behind in this section. But what's great is if you bury your face in those identities, you are ahead already. That's because this is just, do you see the pattern? That's the name of the game of this section.
Have you taken, what was it, engineering or?
Oh, it's like what, like intro?
Intro to
I think I'm taking it this semester. I still haven't taken it.
Intro to what?
I haven't.
What did you take?
Yeah. And then I'm gonna move this over here. That's the stuff to memorize.
This semester.
He literally gives you a textbook at the beginning. You take it with crayons?
Yeah, I will be.
Yeah, he gives
Intro to
you
engineering? Wait,
Yeah,
you taking the next semester?
I think so. Yeah. Are we gonna be in the same class?
Oh shit.
Struggling. We're probably. I mean, y'all see me. Y'all.
Hold on, wait. Let me see.
You'll see,
What time does that class have?